Alright, we're going to look at 8.1, volume of prisms. So you can see on the front page they give you some examples of prisms and they label the bases. There's also a formula here in the gray box that you're going to use. You just got to make sure, like it says here, that when you use B, it's the area of the base. So we're going to have to use some of the area formulas that we talked about in Unit 7. At the bottom of the page, you'll see 3 examples. One has a cube, a triangular prism, and a rectangular prism. And notice that each of them, you'll see that big B, they take those big B's, and what they do is they label the bases as the area of those shapes. So like in the first one, the area of the square is the 5 times 5. And then in the second one, you'll see that for the area of the triangle, they use the area formula 1/2, and then they have the base and the height of the triangle is 5 times 8. So we're going to look at 3 examples on the next page that you write down in your notes. The first one is a rectangular prism, and they kind of went ahead and labeled the base figure for us. So we're going to use that formula. Now, that big B is our area for our rectangle. So in those parentheses, I'm going to put that area for the rectangle, which would be 20 times 6. And then the height is going to be the number that you multiply that base area by. So that height is going to be 14. So in the calculator, what we'll do is we'll type in 20 in parentheses, 20 times 6 times 14. And that'll give us our area, or excuse me, our volume, which would be 1680 centimeters cubed, because it's a 3-dimensional shape. So then going to the second one, similar to the last one, we got a base figure that's a triangle. So when we use our formula, we're going to have to use for the base area 1/2 BH. Now, we don't have the height for the base figure, but we do have a 5 and a 13, and a 13 happens to be the hypotenuse. So to find x, we're going to have to use Pythagorean theorem on that triangle. So we've done this problem a couple times. Square each number. 25,169. Subtract 25 on each side. You get 144, and then take the square root, and then you get that x is going to be equal to 12. So for the triangle, the area of the triangle is 1/2 times 12 times 5, and then the height of the prism is going to be 15, because that's the distance between the 2 triangles. So kind of like we just did, I'm going to put all that in the calculator. We got 1 divided by 2 for 1/2 times 12 times 5. Close my parentheses and then do times 15. So we get a volume of 450, in this case centimeters cubed. Now for the third question, we don't have a height for the triangle, but we are going to use the same formula that we just did. So I'm going to draw in a line that's going to represent that height. And I know because of the markings that each of these sides in the triangle is going to be 6. So what I'm going to do first is I'm going to use Pythagorean theorem again to figure out that height, which is x. So I know that that height is halfway across, so I can use 3 squared and x squared for a and b, and then it's going to be equal to 6 squared. So I get 9 and 36 when I square them. Subtract 9 on both sides, we get 27. And then I'm going to round this answer to the nearest tenth. So if I do second, get my square root, square root of 27 is going to end up being 5.2. So x, my height, I'll label it as 5.2. So when I put everything in the formula, I got 1/2 times the base, which is 6, times 5.2, and then I'm going to times that by the height of the prism, which is 10. And then I'm going to go back to the calculator and put in everything I just wrote down. So we got 1/2 times 6 times 5.2, close parentheses, times 10. So we end up getting 156 centimeters cubed for the volume. So before you do any of the problems, make sure that you have all the measurements you need. And like we did here in the second problem and the third problem, you may have to use Pythagorean theorem or sine, cosine, tangent to find one of the missing values.